Okay, in this video we talk about how to simplify radicals in the form of square roots. Okay, now right here is a list of at least up to 15 perfect or 225 perfect squares. Now 1's a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 2. 9's a perfect square because 3 times 3 is 9. 16's a perfect square because 4 times 4 is 16. And you get the idea, okay, as I go down that list. Now, simplify means no decimals, okay? Well, this first one's easy because the square root of 100, I know that that's equal to 10, so I just fill that in. I put 10, circle it. Now, the square root of 63 is a different story because unlike 100, where that's a perfect square and it's 10 times 10, there's no integer times itself that's 63, okay? I don't see that. So what we do, we're going to put the square root of 63 over here. Okay. 63 is an irrational square root. Okay. This is what I don't want to see. Second, 63. No decimals. Okay. That's not how you simplify. That's how you would approximate or estimate it, but I want a simplification that's exact. Okay. So this is what we're going to do when we get this is called an irrational square root. Okay. Meaning the square root of 63 is an irrational decimal that just goes on forever. But there is a way to simplify it so it is exact. If you've taken geometry, you've already learned this. Okay. So what you do on an irrational square root, you put a division sign, and then you're going to divide that up into two square roots. Okay. Whatever I put here and whatever I put here has to equal 63. But we want whatever's here to be a perfect square root, a perfect square. So what I do is I go 63 divided by. Okay. Now I'm only going to try to divide by the perfect squares. Okay. So the first perfect square I have that's smaller than 63, don't even waste time with the ones bigger, is 49. Okay. So we know 63 is not going to divide by these perfect squares that are larger than 63. So what I do is I go smaller. The first perfect square smaller than 63 is 49. So is 63 divisible by 49? No, I got a decimal. So I hit clear and I go 63 divided by again. Now I see if it's divisible by 36. Got a decimal. 63 divided by 25. Decimal. Okay. 63 divided by, you'd go with 16. Decimal. Okay, 9 worked. Okay, but you don't put 9 and 3. You put 9 and 7. Okay. Because 63 is divisible by 9 and the quotient is 7. 9, 7. What happens is the square root of 9 is now replaced with 3. 3 is my coefficient now. So the answer is 3, and then we put square root 7 right next to it. You can't multiply the 3 and the 7, so just come over here and fill that out. 3 square root 7. Okay. Now the square root of 200. Now does it appear that 200 is a perfect square? No, because it would be right here if it was. Okay. So again, that's going to be an irrational square root. If it's not a perfect square, it's irrational. Okay? So you put IRR next to it. And when you get an irrational square root, you just bring it over here and do what we did on the last problem. So 200 is the product that I'm trying to divide into two factors. Okay? The first factor I want to be a perfect square. So is 200 divisible by 196? No. 200 divided by. Is it divisible by 169? No. Is it divisible by 144? No. How about 121? No. How about 100? Yes. So don't put 110 in there though. You put 102. You divided it by 100 and we got 2. 100 times 2 is 200. So the square root of 100 turns into 10. So we have a coefficient of 10 with a square root of 2. I'll bring that over here. Okay. That's your answer. This is where I want to see the answer. Okay, the square root of 45, again, 45 is not a perfect square, okay? So, it's an irrational square root. So to simplify irrational square roots, we bring the square root value over here, put the division sign, and then square root times square root. So 45, is 45 going to be divisible by 36? No. Okay. But by 25? Nope. By 16? Nope. By 9? Yes, but it's not, you don't put 9 and 3, you put 9, 5 within the two square roots. Because 9 times 5 is 45. So then the square root of 9 turns into 3. Okay? So we have integer 3 with a square root of 5. 3 square root 5. Okay, the square root of 112. Okay? Well, I don't see 112 here, so there must be no number times itself that's dead on 112. So we put IRR, irrational. So we bring the square root over here, division, and go from there. So I go 112. You'd start with 100. No, that's 11.2. That's 1.12. Okay. Decimal. 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 16 and 7. Okay. Okay, so the square root of 16 is 4. Okay. So this equals 4 square root 7. Okay, just put that down here. There's your answer. Okay, 343. Now I know I didn't go to 343. So to see if it's irrational, you just go second square root. And if you get that long decimal that never ends, you know that's irrational. Okay? So we need to simplify the irrational square root. So divide by. Okay, so 343. I would start with 225 because that would be the first number that's smaller. Decimal. Got a decimal on the 196. Decimal. 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 That's 3.43. It's not a decimal. You got to be patient. If all else fails, you know it's going to divide by 1, but keep going. 49. Aha. So I put 49, 7. Now the square root of 149 is equal to 7, so this is a rare one where we get the same coefficient as the square root. Okay, so I want it put over here, 7 square root 7. Okay, now this one's a little bit different. Okay, you got 4 times the square root of 12. You actually have a coefficient in front of your square root to begin with. Okay, here's how we handle that a little bit differently. You bring the 4, after the equals, you bring your 4 right there and put times. Now how about and you can't take 4 times 12, okay? You can't take the coefficient times the number in the square root. It doesn't work that way, okay? Because this is a value of 4, a 4 integer, 12 is a square root, so don't multiply those. You're not able to do that. Okay, so the square root of 12. Is that rational or irrational? Well, it's irrational because 12 is not a perfect square. So I bring over the square root of 12 and just do what I have been doing. Okay, trying to divide it into 2 separate square roots. Okay, this is the product. We want to find the 2 factors, and then one of the factors, the first factor, we want that to be a perfect square. So 12, well 12 is pretty small, okay, so it falls right in between the 9 and the 16, so you start dividing 12 by 9, that's a decimal, then by 4. Okay, that worked. But again, you don't put 4 and 2. You put 4 and 3. Because 12 is 4 times 3. Okay? But then the square root of 4 turns into 2. Now, you got one extra step to do. So after this 4 times, you do what you have been doing and bring over 2 square root 3. Now, this is not simplified, okay? You put another equals, and you're able to multiply the 4 and the 2. Those are both coefficients, okay? You had the coefficient from the original problem, and then this coefficient 2 that you just came up with. So 4 times 2 gives me an 8 product, and then the square root of 3 is attached to the 8. So the coefficient's 4 times 2, which is 8. Okay, and then this one's kind of like it. So you put equals. After the equals, you put the 8 in front, and then you just zone in on the square root. Okay, 80. Now, 80 is not a perfect square. There's no integer number times itself. It's 80. So we put IRR. So we put square root of 80. Square root times square root. Okay. So 80. What can we divide 80 by? 64, no. Okay. 49, nope. 36, nope. Nope. 16 and 5. So we replace the square root of 16 with 4. And the square root of 80 equals integer 4 times the square root of 5. Now we bring that over here, but now we need to multiply the two coefficients. So that's going to be 32, and then the square root of 5. Okay, 8 times 4. You need to multiply those. Okay, put that v right there. Okay, 4 times 2 is 8. 8 times 4 is 32. Okay, now number 1, we're actually going to do together because that's not irrational. Okay, 16 is a perfect square. It's 4. So you have no business putting IRR and taking it over here and dividing. You just put 4, answer. Now the other ones are irrational. You're going to have to do the irrational division, but not on this one. That's like the first one we did in this packet where the square root of 100 was 10.